Hello again, everybody. Today, we're going to continue on with limits, and we are actually going to work on some limit magic today. Some of the stuff we're going to do is pretty algebraically intensive, and it kind of seems cool, how you can manipulate things and all of a sudden you get an answer. So let's go ahead and jump right in. I want to start off with an example here. And what I've talked about a little bit in our last lectures on limits has been this idea of doing a direct substitution. And so taking this x approaching 2, taking this 2 and just plugging it in everywhere that you see an x. And what I want to really harp on today, and even for the rest of the class, what I'm really going to harp on with limits, is that you always should start off by doing a direct substitution. Because as we'll see today, sometimes direct substitution does not work, but if it does work, you're done and you just get an answer out. And we've seen several limits already where we just do a substitution, we get an answer, and everything's all fine. So we're always going to start off with a direct substitution. That's always going to be our first step. And so that I don't lie and so that I don't, be a hypocrite, let's go ahead and actually do this. So if I start off with a direct substitution and take the limit as x approaches 2 of this function, and let's just directly plug that 2 in. And I like to put a little ds above my equal sign when I do a direct substitution, just to make it very clear that that's what I'm doing. When we do a direct substitution, we don't have a limit anymore. The limit goes away because we're actually evaluating the limit itself. So I'll just take this 2 and I'll plug it in everywhere that there's an x. And if you do this, you get 0 over 0. And remember, we talked about 0 over 0 before. This is an indeterminate form. And indeterminate forms, they're bad. We don't like them because they don't tell us what the answer is. There's no way that I can tell you, what this limit evaluates to. If I do a direct substitution, it evaluates to 0 over 0. And that's not a viable answer. It's not a choice that we're allowed to, give as an answer. And so what we have to do here is we have to try something else other than just immediate direct substitution. We tried a direct substitution, it didn't work. We got an indeterminate form. So that's fine, but we've got to do something else now to rewrite this limit before we can do another direct substitution. And what you might have noticed, or maybe it's caught your eye, is what's already up here. That's going to be factoring. We're gonna in this case, we're gonna actually take this function, we're going to factor it, and that'll lead to some cancellation. And so what I really want to make clear is that today in this entire lecture, we're going to see a bunch of different types of ways to rewrite limits. So here we're going to do factoring and then things will cancel. But really, we're going to see a whole lot of methods on how to solve limits if you get 0 over 0. So on all these limits today, I'm going to start off by doing a direct sub, and we're going to get 0 over 0, which means we have to do something else. And that's sort of our magic, right? That limit magic that we do, that's something else. And there's a whole lot of different types of something else's that we can do, and we're going to go through all of those today. So let's go ahead and let's actually just look at this. And let's see what happens if we factor. So if I take the limit as x approaches 2 of x squared plus x minus 6 all over x minus 2, I'm going to factor that top, that numerator. And notice here that I'm not doing a direct substitution yet, so my limit needs to stay there. If you just don't write limit, then that's incorrect mathematically because we have not evaluated the limit yet. So I still need that limit as x approaches 2. But this numerator factors into an x plus 3 and an x minus 2. And what you can probably see here is that we've got some awesome cancellation there. And that's great. We like that. So now I have the limit as x approaches 2 of x plus 3. Be careful and make sure that you put parentheses there, because if I don't put parentheses, then that could be read as the limit as x approaches 2 of x and then add 3. So just be careful there. So we want those parentheses. And now at this point, I can do a direct substitution. And I'll note that when I do that direct substitution, I don't get 0 over 0. In fact, there's not even a fraction here, so it's not even possible for me to get that 0 over 0 indeterminate form. And this I love. We get an answer, it's 5. Boom, we have evaluated the limit. And we evaluated it using a direct substitution, but before we got to that direct sub, we had to do some other work. And that other work, that magic, if you will, is factoring and canceling. And so that's one way, that's a common way that you'll see, limits be posed to you. You'll have a limit with a function here that you'll need to factor things and cancel. So let's go ahead and do another example here. There's that work for that one. Let's do an example here. We'll take the limit as x approaches 3 of x squared minus x minus 1 all over x plus 1. And so we look here and we go, okay, great. I should take this and I should probably factor it, right? I mean, take a look, the slide says factoring and cancellation, right? This looks an awful lot like that last problem. I mean, look at this right here and look at that right there. I mean, they look basically the same way. So I should try and factor this. So let's go ahead and do that. Well, I'm not doing a direct sub yet, so I keep writing limit. And if I try and factor this top, we actually get stuck here. That's kind of tough to factor. And so you might sit here and you might struggle for a little bit. You might try and factor it. I've seen a lot of people draw their little X, for their factoring. They put the 4 things in there. But here's the point that, again, I really, really want to harp on. And I've kind of done this purposefully. We always need to start with a direct substitution every time. Like I've said, if you do a direct substitution and you get an answer, you're done. If you get 0 over 0, then that's bad. You've got to do some other work. But if I start off immediately with a direct substitution, then I could be just done. I could have my answer. And again, because I'm directly subbing in now and I'm evaluating that limit, I don't want to write that limit LIM anymore. And you'll notice here, you end up with 5 over 4. And we're done. There's no other work to do. So maybe I tricked you by starting off with, hey, let's try and factor this. But you should always be starting with a direct substitution. And this is a great example of that. I can give you a limit that looks like, hey, I got to factor this. I've seen a problem like this where I got to factor. But direct substitution is actually the way to go. And so I'm going to keep harping on this. Always start with a direct substitution. If you then get 0 over 0, that's fine. You just have to do some other algebra. So let's move on and let's look at some other cases here. There's the work there. Let's look at some other cases here. So we're going to take this limit, and what's the first thing we're going to do? We're going to do a direct substitution. We're going to try it. If it doesn't work, that's fine. But if it does work, then we're sort of in heaven. We're just done with the problem and we get to move on. So if I do a direct substitution here, then I'm going to get square root of 4 minus 2 over 4 minus 4. That's 2 minus 2 over, still I'll just write 4 minus 4. That's 0 over 0. Uh-oh. Indeterminate form. We don't like that. We don't like the indeterminate form. This is not a viable answer. If you boxed that and wrote that as your answer, I would mark you off. If you took this one step further and you said, oh, this is equal to 0, that's bad. It's not equal to 0. It is an indeterminate form. It is unable to be determined. Its value is unable to be determined. So we have to do something else here. We have to algebraically manipulate this function before we can do a direct substitution. And that, again, that's what we did back here. We took this function here and we algebraically manipulated it. We didn't change what it actually is, but we just manipulated it algebraically. And that allowed us to do some nice cancellation. You know, we were on our way there. So here, the question is, well, what the heck do I do? I've got this function here that gives me an indeterminate form. So I have to do something to it in order to rewrite it so that a direct substitution works. And this is not obvious at all. I wouldn't expect anybody to look at this and know exactly what to do. So I'm just going to go ahead and tell you, or rather show you what we're going to do. And that's multiply by 1. And that sounds almost too simple, but I'm going to multiply by 1 in sort of a special format. And so what I'm doing here is, for now, forget all this stuff. Don't even look at any of that. Just look at this guy right here. That's boxed is equal to 1, but I'm just writing it as square root of x plus 2 over square root of x plus 2. It sounds redundant. You might think, well, why the heck am I doing this? We'll see in just a second how it works out algebraically. But what we're doing here is I'm taking this function and I'm multiplying it by something that's just equal to 1. And that doesn't change it, right? Obviously, if I take, the number 7 and I multiply it by 1, I just still have 7. It doesn't change it at all, right? If I take the number 7 and I multiply it by 3 over 3, which is still just 1 in disguise, it's still 7. I still just get 7 out. And so that's what we're doing here is we're taking this function and we're multiplying it by 1. Now, the question on everybody's mind should be, well, how does he know that this is what I need to, multiply by? And what we're doing here is we're multiplying by the conjugate of this numerator. And in fact, I'm choosing that numerator because of this square root. And we'll see how this works out algebraically. But basically what I'm doing is I'm looking at this function here and I'm saying, hey, I've got this square root of x minus a 2. So what I want to do is I want to multiply by the conjugate, which is square root of x plus 2. So I change that sign. I flip that sign. We'll do several examples of this, so we'll see slight variations here. But this right here, this step of algebra, this is gonna get us to our answer eventually. So let's go ahead and carry out the rest of this work here. I'm going to give myself a new page and let's work on this. So I'm going to have the limit as x approaches 4 of square root of x minus 2 all over x minus 4. And like I said, a direct substitution, like I showed you, a direct substitution does not work right off the bat. It gives us 0 over 0, so we have to manipulate this limit in some fashion. And that manipulation method, sort of a new manipulation method that I'm teaching you, is multiplying by the conjugate. Put that in parentheses just to be very clear. And if I do this, I'm going to take that, I'm going to take the top and the bottom, and I'm going to distribute. I'm going to FOIL it out. So first, outer, inner, last. I'm going to have a root x times a root x minus 2 root x plus a 2 root x minus 4. Well, I guess I could write that as 2 times 2, just to be very clear. And so all I did there was I did a first, outer, inner, and last right there. So just that foiling that we're used to doing. I can do that on the bottom as well. And what you'll get in the habit of, and you'll see this, I am actually not going to FOIL out that bottom term. For now, you're probably wondering why, but you'll see in just a second why I'm doing that. Things are going to cancel nicely. So I'm going to leave it. I'm going to leave it like that denominator. I'm going to leave it in that sort of factored form. I'm not going to distribute this out. That's okay. And now let's go ahead and simplify that numerator. What I notice here, first things first, is that these terms cancel with each other. There's a minus 2 root x and a positive 2 root x. And that's great. Those just go away now. So I have the limit as x approaches 4 of root x times root x. Well, that's just an x right there. So this root x times root x just becomes an x. Again, those terms canceled, and I'm left with that 2 times 2, which is 4. So I have that x minus 4 right there. And now you can probably see why I didn't want to distribute out this denominator. And that's because these x minus 4s are going to very nicely cancel here. Make this look a little nicer. There we go. So these x minus 4s are going to cancel very nicely. And what I'm left with is the limit as x approaches 4 of 1 over square root of x plus 2. And at this point, I noticed something here. I noticed that I have a 1 on the top. There's nothing else. It's just a 1. So if I were to do a direct substitution, it's actually not possible for me to get 0 over 0 because I don't even have a 0 on the top. There's no way for me to get a 0 up here. This is just 1. So I always am going to have 1. So that lends itself to me knowing that I can do a direct substitution right now. And I'm going to go ahead and do that. I'll put a little label here, ds. And if I do that direct substitution, everywhere I see an x, I replace it with a 4. I end up with my final answer of 1/4. And there we go. We've gotten an answer. It is not 0 over 0 like we saw back here. Here, when we just started off with that direct substitution, we got 0 over 0. That was bad. It's an indeterminate form. So I do this fancy multiply by the conjugate, and after some manipulation, that ends up working out in our favor, and we end up getting an answer that we like, 1/4. And again, so that conjugate, that idea of this conjugate here, it's if I give you a plus b, then the conjugate is equal to a minus b. If I gave you a minus b, then the conjugate would be a plus b. So that's how I'm getting those conjugates there. That's how I arrived at my root x plus 2. You might ask at that point, well, why didn't you multiply by the conjugate here? X plus 4 over x plus 4. It's a great question. It's a great point. The simple answer is that I want to multiply by the conjugate of the thing that has that square root there. That's not a great answer because what if there isn't a square root there? What if there's something else? So a better answer might be that it just takes some practice. I've obviously done a lot of these limits in my lifetime, and so I can look at a limit like this and know which part of it I want to multiply by the conjugate of. It just takes some practice. We're going to do a bunch of these examples so you guys will get really used to them. Let's go ahead and do one more example. Here's all my work for what I just did there. I'm just going to skip over all that because we just did this. So let's do one more example here. I'm going to have the limit as x approaches 36 of x minus 36 over square root of x minus 6. Let's give myself a new page, but actually even before that, I want to write here, I want to start off with a direct substitution, right? I almost skipped over that. The very first thing we got to do is a direct substitution, because like I've said, if you don't get 0 over 0, then you're just done. If you do get 0 over 0, that's fine. And, you know, we'll move on. We'll do our fun algebra or conjugate multiplication. But if I don't get 0 over 0, then I'm just done with the problem, and it's nice and quick. And here you're going to see we are going to get 0 over 0. That square root of 36 goes to a 6, and then I subtract 6 off of that. I get 0 over 0, indeterminate form. Oh no, yikes. We don't like it. We're going to move on. We're going to have to adjust the x minus 36 over square root of x minus 6. We're going to have to do something to it in order to rewrite this limit so that we don't get a 0 over 0. So let's go ahead and do that. Let's take limit as x approaches 36 of x minus 36 over square root of x minus 6. And as you could probably guess, we're going to do a conjugate multiplication here. So again, I write my limit as x approaches 36 because I'm not evaluating the limit yet. I'm just rewriting it. And so the question is, well, we're going to do conjugate multiplication, but which part of this do I choose for my conjugate? Which thing do I multiply by? And before, we saw that we looked at the numerator and we took the conjugate of that. So some people might say, hey, let's do the numerator. Let's multiply by x plus 36 over x plus 36. However, I don't really want to do that because I see this square root down here in the denominator, and that to me, that's sort of a trigger there that lets me know, I should do the conjugate of that part with a square root in it. And so I'm going to multiply by square root of x plus 6 over square root of x plus 6. And I'm actually going to change the color here of this part that I'm multiplying by just to make it stand out a little more. And again, that what's in the orange there, that's just equal to 1. So I'm not actually changing anything. I'm not morphing this into a different identity. It's just me multiplying something by 1, and that's fine. So when I do that, again, we're gonna foil things appropriately. We're also going to do that little trick where we don't foil, in this case, the numerator. So I'm going to leave that numerator unfoiled. I'm going to leave it in a factored form. This denominator I'm going to foil, and you'll start to see this pattern here. Square root of x and the square root of x, that gives me an x. The minus 6 root x and the positive 6 root x are going to cancel. So that's good because we get some cancellation. And then I'm going to be left with that minus 6 multiplied by positive 6, which gives me minus 36. And we're starting to see this happen over and over and over again. X minus 36, x minus 36. They cancel. That's wonderful. We love it. Now we end up with this point here. Limit as x approaches 36 of the square root of x plus 6. It's impossible now for me to get 0 over 0 because I don't even have a fraction. There's not even a fraction here. So I'm not worried about any indeterminate forms. Because I'm not worried about them, I'm going to do a direct substitution. You write that in red, make that stand out. So I can do my direct substitution. When I do that, I get square root of 36 plus 6, which is equal to 6 plus 6, which gives me my final answer of 12. That doesn't look like a very good 12. Let's write that a little better. We got 12 right there. Great. Let's go ahead and box that. That's our answer. And again, I've sort of taken two two shortcuts here. I haven't FOILed this guy out. You're going to see that happen quite often. I'm going to leave this in a factored form. And then on this foiling on the denominator here, you'll notice that we're always going to have that inner and outer. Those are going to cancel with each other. And that's by nature of the fact that we've chosen to multiply by the conjugate. So because I'm multiplying by the conjugate and this minus and plus are opposite signs, you will always have that cancellation there. You should, at least, as long as you're doing things correctly. So there we go. There's a second example on conjugate multiplication. Let's go ahead and move on to another type of sort of limit magic that we'll do. And here's this limit here. So here's my question to you. Well, what should we do? What's the very first thing we do? Direct substitution. Every time, direct substitution. Don't ever forget that. So we're going to start off x approaches 7 of 1/7 minus 1 over x all over x minus 7. And then if I do my direct substitution, I'm going to get 1/7. Notice I don't write the limit anymore because I'm evaluating it. I'm doing my direct substitution, so I don't have to write LIM. I plug in 7 in for x, and I end up with 0 over 0, indeterminate form. We're happy and we're sad. We're happy because we know that we have, that we have a little bit more work to do. We know that this doesn't give us a definitive answer. We're sad because we'd love for it to just give us a definitive answer. But we got to do some more work. So the question here is, what manipulation do we do? What algebra can I do on this guy right here to change it so that I end up not getting an indeterminate form? And what hopefully you can see here, this one is, while it's still tough to recognize, some people might notice, I could find a common denominator on the 1/7 and the 1 over x. So within this numerator here, I could find a common denominator. That sounds a little funky, but I can just look at that 1/7 and that 1 over x, and I can find a common denominator. So let's go ahead and actually do that. And let me give myself a new page here. We'll rewrite this limit out. Limit as x approaches 7 of 1/7 minus 1 over x all over x minus 7. And what you're going to notice for the next couple steps of algebra, I'm kind of just going to ignore this x minus 7 on the denominator. I'm just going to keep copying it over and over and over. So we're going to have a limit as x approaches 7. Let's find a common denominator on that numerator. So just looking at that numerator, let's find that common denominator. And what I think is that common denominator is going to be 7x. So if I multiply the 1/7 by an x over x in there, let me do that with a different color here, then I'm going to end up with my x over 7x. If I take the 1 over x and I multiply it by 7 over 7, then I'm going to have minus 7 over 7x. And this is great. This gets us on our way. Because they have so again, just looking at the numerator, because they have the same denominator, I can write them together. And I have an x minus 7 all divided by 7x right there. That's all fine and dandy right there. At this point, we can just do some simplification. If you're not already, get very comfortable with dealing with fractions in fractions. You should be able to tell that this ends up with the 7x down here multiplied by the x minus 7. And then We see this cancellation again. That x minus 7 cancels, and that's good. That's what we're looking for. Because now I have the limit as x approaches 7 of 1 over 7x. And I rejoice, I get really happy because there's no 0 on that top. There's no x's. There's no way for me to get 0 on the numerator. That numerator is just 1. So if I do a direct substitution, I'm not going to get an indeterminate form. And that's good. We don't want that indeterminate form. So I'm going to do that. I'm going to get 1 over 7 times 7, which is just 1 over 49. And that is our final answer. We've evaluated this limit. And there we go. We've got our 1 over 49 as our answer. And so that's going to be sort of this method of finding a common denominator. Let's go ahead and do another example of it, and that'll wrap us up with these sort of methods. So let's skip through all this. This is just that same work that I did, just typed out. Got all that written there. As you can see, we get that 1 over 49 right there. So let's go ahead and look at this example here. What's the first thing that I do? Please do not say common denominator here. We have to do a direct substitution. That is always, I know I'm probably sounding annoying saying that over and over, but that's always the first thing that we do. Just copying this guy down. X plus 1. So let's do a direct substitution. And quite shockingly, we're going to get 0 over 0. Four plus 3 times minus 1 there, plus 1 over negative 1, over negative 1 plus 1. This work is, there's a couple more steps here than what we've done before. That's okay. 4 minus 3. I'll just write minus 1 because that 1 over negative 1 simplifies to that. I get a 0 there. This is 1 over 1 minus 1 all over 0. I end up getting just 0 over 0. Indeterminate form. We're not done with the problem. We got to do some algebra. And when you see a limit of this form, the first thing that I think is let's find a common denominator on the terms in that numerator, those two fractions that are sort of hiding up there. So let's give us ourselves a new page. Let's go ahead and write this limit out again, and we'll work it through. Limit as x goes to negative 1 of 1 over 4 plus 3x plus 1 over x, all over x minus 1, sorry, x plus 1. And we're going to find a common denominator. I'll do this a little bit more quickly than I did last time. So here I'm multiplying by an x over x. Here I'm going to multiply by a 4 plus 3x over a 4 plus 3x. So I'm not changing these because I'm just multiplying them by 1 in a weird form. But now I have a common denominator here. And so I can sort of lump those fractions together. And I end up with x plus 4 plus 3x all over x times 4 plus 3x all over x plus 1. And again, fraction math, get comfortable with this. We're going to be doing a lot of it. I can rewrite this as x plus 4 plus 3x all over x times 4 plus 3x times x plus 1. We can do some simplification here. On the numerator, that x and the 3x add together, and then I have 4x plus 4 all over x times 4 plus 3x times x plus 1. I'm running out of space here, so let's go ahead and copy this onto a new page. Copy the original limit as well, just so we can see it. All right, so we're here. We've done that simplification. There's another step we can do of simplification here. We can factor out a 4 from the top, and then I'm left with an x plus 1. And I like that because now we can cancel those x plus 1s. And this makes me very happy because our numerator is just 4. So there's no way that I'm going to get 0 over 0. That's just not going to happen. So I can do my direct substitution. I end up with 4 over negative 1 times 4 plus 3 times negative 1. And if we do some simplification there, we will end up with our final answer. We'll get negative 4. I'll let you guys do that simplification on your own. Oop, I missed a parentheses there. There we go. Boom, we get negative 4. That's our final answer. There's another example of doing things with a common denominator. Here's all that work right there. I just want to wrap up by just sort of doing a recap of the methods that we've seen here. So we've looked at when we have a limit, we always start with a direct sub. And then if you get 0 over 0, then we come down into one of 3 methods. There are obviously a lot more methods, but these are the 3 that we've talked about today. We just finished off with common denominator. Before that, we did that conjugate multiplication. And we started off with that factoring and canceling. And now, obviously, like I just said, there are a lot more things that you could do here. You know, I could keep on teaching you about, you know, more and more and more things here. We're just going to focus on these 3 for now. We may see more a little bit later in the course, but these are the 3 that we talked about today. And just that whole idea that you always start with that direct substitution. If you get 0 over 0, then you've got some other sort of algebraic tricks at your disposal to edit the function and change it just a little bit. And I'll go ahead and leave that there. That's it for this portion of the limits lecture.